In this video, we're going to talk about the intersection of two vector lines in a three-dimensional space. Okay, so what are the three possible scenarios? Okay, so they could be parallel, or they could be intersecting, or they could be skew. Right? Skew means that they are not parallel to each other, but yet they do not intersect. Right? So that can happen in the three-dimensional space. Okay, so let's look at these three examples, right? So it's designed in a way that each example corresponds to one of the scenarios. Okay, so in general, what is the procedure, right? What should we think about? What is the thought process to determine whether it is parallel, intersecting, or skew? Okay, so first thing to look at would be the direction vector. Okay, so if you notice that the direction vector, one of them is a constant multiple of the other, then that means these two lines are parallel. Okay, so in this case, it's quite obvious, right? Negative 2, 3, 4 is 2 times of negative 1, 1.5, and 2. Okay, so 2 is a constant multiple, right? So therefore, we can say that line 1 and line 2, they are parallel. Okay, so let's look at example 2. So you notice that the direction vector, right? One of them is 1, 2, 1, and the other one is 1, negative 1, 0, right? So it's quite obvious that they are not parallel, right? Because one is not a constant multiple of the other. Okay, that means they could be intersecting or they could be skewed. Let us examine which one it is, right? So to do that, okay, we have to equate them together, right? So this is how we equate them together. Right, so this will be 0 plus lambda, and that's equals to 5 plus mu. Okay, negative 1 plus 2 lambda equals to negative mu. Negative 2 plus lambda is equals to 0. Okay, so from this equation, right, we can deduce that lambda is equals to 2, right? And then from here, if you sub lambda equals to 2 into this equation, right, negative 1 plus 2 times 2 equals to negative mu. Okay, so that tells us that mu should be equals to negative 3. Okay, and then since we know that lambda is 2 and mu is negative 3, right, let's substitute both of them into this equation. So this is 2 and this is 5 minus 3. Okay, does it make sense, right? So you get 2 equals to 2. Okay, that makes sense, right? So that is good. That means this line 1 and line 2, they do intersect, right? So they do intersect. As long as you have a mu and a lambda, right, that satisfies all three equations, right? Then we know that they intersect. Okay, so if you want to find the point of intersection, you can substitute either lambda equals to 2 into equation 1 or mu equals to negative 3 into equation 2. Okay, so let me substitute lambda equals to 2 into equation 1. Okay, let's see what we'll get. Okay, so there'll be x, y, z equals to 0 plus 2, negative 1 plus 2 times 2, and negative 2 plus 2 times 1. Okay, so that is 2, 3, 0, right? Okay, so this is basically the point of intersection between line 1 and line 2. Okay. Okay, now let us look at the third example. Okay, so same thing, right? If they are not parallel, we are going to equate them together. Okay, so we're going to get 0 plus lambda equals to 2 plus 3 mu. Right, and this is 1 plus lambda equals to 2. And 6 plus lambda equals to 3 plus 2 mu. Okay, let's use this to help us, right? So we can deduce again that lambda is equals to 1. Okay, let's substitute lambda equals to 1 into, let's say, this equation, right? So this is 6 plus 1 equals to 3 plus 2 mu. Okay, so that means this one would be 4 equals to 2 mu, right? And mu is equals to 2. Okay, so now we have lambda equals to 1 and mu equals to 2, right? So let's test it on the first equation. Okay, so this is 0 plus 1 equals to 2 plus 3 times 2. Okay, well, we get 1 equals to 8, right? So it doesn't make sense. Okay, so that shows that they do not intersect. Okay, so remember, right, we have 3 possible scenarios. So they are not parallel and they do not intersect. That means they have to be skewed. Okay, right. So the third example is skew. Okay, so that's the end of the video. Right, hope it was helpful.